Hey, amazing math students. It's your math teacher, Mr. Murphy, coming to you from our classroom in room 122 at Oshkosh North High School. And today I'd like to welcome you to our lesson on section 5.1, which is called Randomness, Probability, and Simulation. The learning targets for today are to interpret probability as a long-run relative frequency, and to use simulation to model a random process. So let's get to it. We want to know, how good is Mrs. Gallus at free throws? Well, I don't know Mrs. Gallus. Maybe you do. I don't know. But Mrs. Gallus thinks she is a pretty good free throw shooter. How many free throws would you like to see Mrs. Gallus shoot before you could be confident guessing her free throw percentage? You'll watch Mrs. Gallus shoot free throws when you are confident, make a guess at her percentage. Well, we're not actually going to watch Mrs. Gallus shoot free throws, and I'm not going to shoot free throws for you either. But I do have the data from Mrs. Gallus's shooting that we'll record together. So we would record this, and actually you would probably list out 80 shots or however many you think it's going to take before you could figure out what her percentage is. I'd be curious to find out what you think. And if you were in class, I would ask you, what do you think? How many free throws should she shoot? Is 80 a magic number, or is there a number less than that? Today, I'm kind of going to go with like 40. Let her shoot 30 or 40 free throws, and then we'll see how she's doing. And we'll go with 80 because, of course, the more the better. So it says, as each shot is attempted, keep track of the number of made free throws and the total number of shots attempted in the table below. When you think you know Mrs. Gallus's true free throw percentage, stop recording. We're going to stop at the 80th shot. So I have the data for you, and it turns out that she missed on the first shot. Sorry. So I'm going to do this as a running total. So she missed on the first shot. So she made 0. So right now, her proportion that's the percentage. Her percentage would be 0. All right, go get him, Mrs. Gallus. She fires away, and the second shot rims out. So she missed again, so she is still at 0. Don't worry, Mrs. Gallus. We know you can do it. Third shot's coming up, and she puts it in the hoop. That is a make. So that's her first make out of 3 shots, so that would be 33%. And she is on a roll. She hits the second shot in the 4th attempt, and that brings her to 50%. All right, so I've seen the data. She probably should have quit at 50%. But she takes the 5th shot, and it misses. So she's now 2 out of 5. And she is at 40%. In the interest of speeding things up, we're just going to give you the data for the next 5 shots at a time. And then at 20, we're going to go 10 shots at a time. So after 10 shots, she had made 4. So that was still 40%. After 15 shots, she had made 7, pretty close to half. That's 47%. Obviously, you're rounding off here. Then after 20 shots, she's made 9. You don't have to round off there. That's 45%. Then she shoots 10 more, and she only made 2 out of those 10. So she's now made 11 out of 30. So she's at 37%. But she's going to do a little bit better now. In up to 40, she makes 6 out of the next 10 shots. So she's at 17 out of 40, which is 43%. And then once she shot 50 shots, she's made 22, which is 44%. The next 10 weren't so kind, though. She made 1 out of those 10. So she went to 23 out of 60, which took her percentage to 38%. But then she picks it up, and she makes 5 more out of the next 10, and that increases her percentage to 40%. And then she makes 5 more on the next 10, which would give her 33 and that percentage would be 41%. So that's where we're going to stop there. Obviously, you could keep doing this. And if you've ever done this yourself, you're going to find that there are confounding factors. After you shoot a certain amount of free throw, your arm is going to start to get tired. I'm going to guess somewhere in here. If you were to keep shooting over and over again, you're going to get a little tired, and it's probably going to make your numbers go down. So maybe she rested in between. I don't know, but you could possibly shoot 80, and in a way, there's another confounding factor that your muscle memory is going to increase. So maybe you'll make more. Anyway, it's going to ask what we think your percentage is going to be. And I'm thinking 41% because that's the most. And I think I would tell somebody I'm going to guess 41%. But for the purpose of this, I'm just going to go with 40% because that's a nice rounded off. We really don't know. And when you start to deal with specifics, my friends, like 41%, people start to think that it was much more accurate than it necessarily is. For example, if you wanted an estimate, you want some work done, maybe on your car or on your house or something. You want some work done. You ask for 2 estimates. One guy comes in and it just says $800. $800, that's his estimate. Okay, another total comes in and it's like $784.32. Now they're both probably just total estimates. But the second one sounds a lot more accurate because he took it right down to the penny. So you start thinking, well, man, he must have thought really hard about that estimate. So maybe it's more accurate. Not necessarily. So just so there's no confusion, just say, hey, it's roughly 40%. Okay, so now we're going to sketch the graph. So I already made this up, so you don't have to waste your time watching me draw a graph. But I did draw this line at 40 because I knew she was going to be about 40%. So when we sketch it, we start off on the first 2 shots down here. She was at 0%. So she's at 0. On the third shot attempt right here, she goes up to 33%. On the fourth attempt, she made it. She went up to 50%. So that's here. You're going to see there's a lot of variability at the start. Then she's down to 40% for number 5. So when you first start these things out, you're going to have lots of variability. The graph is going to be moving all over the place. So we start off at 0. We went up to here, and then we went to here, and then we went down to here. Okay. At 10 shots, where was she at for 10 shots? 10 shots, she's at 40%. So that's going to stay here. I'm just going to, sorry if it's not perfectly straight. There we go. Okay, then at 15 shots, she's at 7. 15's halfway here. She's at 7, that'd be 47%, which would be roughly there. So just making the graph here. It's going along. And then let's see, up to 20 shots was at 45%. So a little bit lower, something like that. Sorry, I shouldn't have drawn the red pen over the top of the green because it's not looking quite so good. But hopefully you can tell that it's still red. And then what's happened after 30 shots, it's 37%. So I'm just going to put the percentage in for the rest of them, 37%. At 40, it's 43%. So up here, at 50, it's 44%. So basically the same, just slightly higher. 60 is 38%. So back below the line a little right there. And 70 would be right on the line, 40%. And 80 is just a little bit above the line. So something like that. So anyway, we can make our line. And I guess the goal would be to be able to predict the future and say, okay, how is this going to go? And roughly it's going to follow the line. You could almost think of this as a regression line in some ways, because it's a line that is going to establish a pattern for our results. And you'll be able to see this when I get done with this in a second. I think next video I'll just draw the graph for you ahead of time. So here you go. So you can see that as the trials go, the graph starts to conform more and more and more to that line, or that imaginary line at like 40%, which that's what I'm guessing her true free throw percentage is, about 40%. Okay, so down here, we should always label the axes. This is the number of free throw attempts. And the other axis is your percent of shots made. I'll try to write it on the side. Percent shots made. Okay, so you should always label your axes when you do a graph. And in fact, you really should label the graph. So let's just call this one Mrs. G's free throws. Okay, so we got our labels in there. AP is going to want you to have labels on your graphs, guys. So make sure that you put those in there. And then we started out at the beginning, and the stuff back at the beginning is pretty unpredictable. So probably, well, I don't know how far you want to go, maybe up to 20 or so, or 15 or 20. That's somewhere in there. This is all unpredictable. We had no idea how Mrs. Gallus shot her free throws. We didn't know. So we're just watching. And after a while, now we start to get to 20. And okay, this is like at 15. We didn't know. We're watching. But after 15 or so, or 20, you start to see that she's about 40%, and then as you get more and more, I'm going to go with 40 today as our predictable area, but I could have gone with 30. But let's just say all this range in here, this was your predictable region, and this over here was your unpredictable region. So predictable and unpredictable. And in here, you can debate that whether it's predictable or not. There's no set number where all of a sudden it goes from unpredictable to predictable. It's just in terms of the relative situation that you're dealing with. So let's answer question number 4. How could you make your guess more accurate? Well, the way that you make it more accurate, guys, is you increase the sample size. She could shoot more free throws. And this is the law of large numbers. The more she shoots, the more that average is going to conform to the true mean. Number 5, Mrs. Gallus has a 40% probability of making a free throw. Actually, you could have gone with 41. If I was doing this for an AP test, I'd have gone with 41. But I just wanted to emphasize to you that the more precise you are, the more people think actually went into the accuracy of it. And this really isn't all that accurate. She shot 80 shots, but there's a lot of factors that could have happened. I mean, if you shot them in a gym, or did you shoot them outside with the wind blowing, or there's lots of different factors. So anyway, it says that to interpret this probability. So if her probability is 40%, I'd say if Mrs. G takes many, many free throws, about 40% of them will go through the hoop as successful attempts. Let's take a look at the important ideas for this particular section in our chapter. Probability, it's the long run relative frequency. So that's what you did here. This is a relative frequency. As you went through, you kept adding on to it, and you went up with 33 out of 80. Before that, you had 28 out of 70. That was your relative frequency because you kept accumulating the numbers. So the long run relative frequency is what we call the probability. Now, this wasn't a simulation. I mean, there's 2 different kinds of probability that you're going to deal with. One of them is called theoretical, and that's the kind that you can figure out, like when we're rolling these dice here. Okay, you can figure out the probability that something's going to happen. Another one is experimental, which was like this: do a simulation. It was an experiment we did. We didn't know what it was going to be. And to be honest with you guys, even for dice, back when dice first came out, yeah, you could figure out the theoretical, but that probably was going to be meaningless because the dice were made. These are all made nice, balanced, and everything. Old dice were made out of bones or rocks or something. They weren't balanced at all. So if you wanted to know the probability of something, it wasn't like 1/6 for like each one of these numbers. You got a 16.7% chance of getting a certain number. That's not the case with the old dice. They were bones and rocks and stuff. And even the first dice that were made with machines weren't perfectly balanced. So people would just roll them over and over again. They'd be riding along in the train or sitting on a sidewalk or something, just rolling dice over and over again to figure out what the probability is. So when they went to gamble with those dice, they could make better bets. Not that we want you gambling or anything, my friends. All right, let's see what else you got. We know the probability is between 0 and 1. It's a percentage. If Mrs. G missed all of her shots, she'd have been at 0. If she made all of her shots, she'd have been at 1. Technically 100%, but 100% is the number 1. In the short term, things are unpredictable, but in the long term, they get to be more predictable. Also, a good idea for you to know is the law of large numbers. If we do something many, many times, the proportion of desired outcomes, which we call successes, will approach its probability. So if you want to know what the probability is, do it over and over and over again. Hey, you know that if you flip a coin, it should be 50% heads, 50% tails. If you do it for 10 times, yeah, good luck trying to get 5 and 5. You might, but you probably won't. You probably get something else. However, and even if you flip the coin 1,000,000 times, it's not probably going to be exactly half and half, but it's going to approach 50%. It's going to get closer and closer to the 50% that you would expect. All right, check for understanding. Let's see how you're doing for understanding all this. Use 4 of the following probabilities to complete the middle column of the table. Then give an example of an event that has a probability. So these are some probabilities. I just picked these here. If the outcome is impossible, it's 0. It can't occur. Something like if you roll this die here, if you roll a 7 with that die, you'd be the first person to ever do it because it's impossible. You got 1 die. Oh, sure, if you had a second die, you got a chance to roll a 7. Sure, you could do that. But if you just have 1 die, it's impossible. By the way, due to political correctness, we don't usually use the word die. It's the singular form of dice. You would call these dice, obviously. In math, we tend to call them number cubes because we do not want to use that word. It's just, just don't want to do it. It's politically incorrect. So you'll hear me say number cubes or dice. Okay, so anyway, how about a certain outcome? Well, you're certain if you roll 1 number cube, you're certain that number is going to be less than a 7. You can guarantee that. It's going to be either 1, 2, 3, 4, 5, or 6. How about an outcome that's very unlikely, like 0.001? That would be the probability that you guess a correct number from 1 to 1,000. For example, if I said, all right, guys, I'm going to pick out a number on a random generator or something. It's going to be between 1 and 1,000 inclusive. Take a guess. Okay, this is your chance that you'd guess it right. How about something that happens more often than not, but does not occur almost every time, like 60%? All right, so if you got this spinner, it's got 5 equal sectors. These 3 are green. There's a red and a blue. So 3 out of 5 would be 60% or 0.6. So you'd have a 60% chance of spinning a green in this particular situation. All right, then you got this game called Wheel of Fortune. You're probably familiar with it. I'm not sure if this is exactly the right percentage, but maybe it is. In the Wheel of Fortune, I'm going to guess it is probably. There is a 1/9 or 11.1% probability of spinning bankrupt on any given spin. Interpret this probability. What does that mean? So that means after many, many spins, about 11.1% of spins will land on bankrupt after you do it many, many times. If 9 consecutive spins on the Wheel of Fortune, you do 9 of them in a row, none of them landed on bankrupt, the next contestant worries that he is more likely to land on bankrupt now because bankrupt is due to happen. You know what, though, guys? Probability has nothing to do with what's due. Each spin has 11.1% probability. It doesn't matter what happened in the previous spin. It does not matter what spins have come before. Each spin is mutually exclusive, meaning that each spin has its own life, its own probability. It's got the same probability every time. If you flip a coin once and you get heads, the next time you flip it, it's still 50% heads, 50% tails. It doesn't mean just because you got heads on one flip, the next one has more of a chance of being tails. Not the case. Anyway, that is all from Oshkosh North High School for this lesson. Want to thank our friends at Stats Medic and want to always encourage you to stay awesome, Spartans.